Hey guys, today we'll talk about biological resistance. Biological resistance is the natural genetic ability of an organism to avoid or repel some sort of biotic or abiotic agent. So it could be repelling some sort of pathogen or some sort of chemical like pesticides or antibiotics. So taking a look at the picture on your screen, you can see that non-resistant bacteria, when treated with some sort of drug like antibiotics, are killed. Whereas resistant bacteria, when treated with that same drug or antibiotic, are not killed and are instead able to continue spreading. So a little background on antibiotics. Alexander Fleming is known to have discovered penicillin, and the way he did this was he had petri dishes with bacteria, and he noticed that bacteria close to mold, and you can see that on the screen right here, the bacteria that were close to the mold were dying, and he was able to actually isolate that mold and identify it as a member of the Penicillium genus, and then it later became the antibiotic penicillin. So that's kind of a little bit of background in antibiotic video, where you start off with non-resistant bacteria, and those bacteria reproduce, and then over time there's some sort of mutation in the DNA that allows the bacteria to resist certain drugs or certain antibiotics. And then over time, when that drug is present or the antibiotic is present, only the resistant bacteria live and then the other ones die off. And then over time, those drug-resistant bacteria multiply and pass on that gene. So taking a look at these graphs, you can see that that first graph shows what it would be like without any antibiotics. So you can see that the bacteria continue to grow over a 24-hour period. Okay? Here in this figure, you can see that antibiotics were used and the bacteria were not resistant. So you saw that within a short amount of time, so within 6 hours, the amount of bacteria decreased exponentially. Okay? And then here you can see that the antibiotics were used, and so it decreased the population of bacteria, but we must have had some resistant bacteria because then the amount of bacteria started to increase again. Okay, so you can kind of see what those graphs would look like. Now we're going to recap the steps that we talked about at the beginning of this video in terms of how resistance builds up. So the first step is that there's some sort of random mutation that leads to variation within a population of bacteria. So say, for example, we're working with E. coli. Then the population of E. coli is exposed to the antibiotic. Those that have no resistance die off, while the ones with resistance survive. And then those survivors reproduce, passing on their genetics that carry that resistance to the antibiotic. And then over time, you find that the entire population now has resistance to that antibiotic. So we're going to look at a specific example called the case of the ticks. So we're going to look at a chemical called permethrin, which is a chemical found in many tick repellents, okay? And you can see an example of an insect repellent. And if you look really closely on your screen, you can see permethrin is one of the active ingredients for this chemical. So this chemical actually affects the nervous system of insects, which eventually leads to paralysis and death of those insects, okay? So we're going to take a case of 15 years ago where there was a population of deer ticks in eastern Massachusetts that was causing issues for the local town, okay? And because of this tick infestation, the town had a lot of Lyme disease going on, okay? So the town provided the residents with something they called tick tubes, which essentially had cotton balls that carried permethrin. So they were just cotton balls dipped in permethrin. They would put them out, and then mice would carry those dipped cotton balls to their nests where the ticks lived. And gradually, most of the ticks were killed off by that chemical. However, 15 years later, the town has an even bigger problem because now the tick population is increasing, but now a lot of these ticks seem resistant to permethrin. So we're going to work with a local scientist, which is just us, and we're going to explain how this drug resistance evolved in the tick population. So what you're going to need for this is a piece of paper and 2 different colored pens. So once again, you're going to need a piece of paper, and half a piece of paper will work just fine. Or you can use the back of an old piece of paper. You just need some sort of scratch paper where you can draw or write on. And you'll need 2 different colored writing utensils. If you've got a pen and a pencil, that will work fine. 2 crayons, a marker and a crayon, whatever you can find, just 2 different colors. Okay, so follow along with me. I'll try to go slow so you can keep up. Okay, you're going to take your piece of paper and we're going to fold it into 4. Okay, 4 quadrants. So we're going to fold once this way. Okay. We're going to fold one more time. Okay, and we're going to go ahead and unfold it now. Okay. So you should have 4 spaces now. And we're going to label these spaces generation 1 all the way to generation 4. So grab your first pen and follow along. So generation 1, generation 2, generation 3, and generation 4. So your paper should look something like this now, okay? Now we're gonna make a quick little key for us, okay? So anywhere you can find some space, I'm just gonna make mine right here. I'm gonna use whatever my first color is, so I've got blue. I'm just gonna shade it in just a little here, and I'm gonna label this as my resistant ticks. Okay. Then I'm gonna take my second color and I'm gonna label that my normal ticks or my non-resistant ticks. Okay, so now in generation 1, we're going to have 2 resistant ticks, okay, and that resistant gene, again, like we saw in the video previously, was from a mutation. So some sort of mutation happened in these non-resistant or normal ticks that led to them having the resistant gene. So we're going to have 2 resistant ticks in our population, and we're going to represent that by 2 circles. So we're just going to make 2 blue circles or 2 circles in whatever color you're using for the resistant ticks. And then we're going to make 18 circles to represent our non-resistant ticks. So I'm going to use red since that's the color I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay. Now, when generation 1 is exposed to permethrin, which is that chemical we talked about, it's going to kill off 10 of the non-resistant ticks. So we're going to go ahead and cross off 10 of these circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 survivors. 2 of them are resistant and 8 of them are not. So in generation 2, we're going to double these guys. So if we have 2 blue or 2 resistant ticks, 2 times 2 is 4. So we're going to draw 4 resistant ticks. Okay. And then we have 8 non-resistant ticks surviving. So we're going to double those. So we should have 16 in generation 2. And we'll use red circles to represent them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Again, when generation 2 is exposed to permethrin, okay, it's going to kill off 10 more of these non-resistant ticks. So we're going to cross off 10 of these red non-resistant circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we have 10 survivors. 4 of them are resistant and 6 of them are not resistant. So again, as we move from generation 2 to generation 3, these numbers will double. So we have 4 resistant ticks, they will double to 8, and we have 6 non-resistant ticks, and they will double to 12. Okay, so let's go ahead and draw generation 3. 1, 2, 3, 4, 5, 6, 7, and 8. So those are my resistant ticks. Then I'm going to continue by drawing 12 of my non-resistant ticks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Again, generation 3 was now exposed to permethrin, and it's again going to kill off 10 of the non-resistant ticks. So we're going to go ahead and cross out 10 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We again have 10 survivors, but this time 8 of them are resistant and only 2 of them are not resistant. So they are again going to double in generation 4. So because I have 8 resistant ticks, I'm going to have 16 in generation 4. So we'll do 16 blue circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. We have 2 resistant ticks and they're going to double, so now we will have 4 resistant ticks in generation 4. 1, 2, 3, and 4. Okay. Now, as you can see, compared to generation 1, generation 4 has a lot more resistant ticks. Here the majority is resistant, whereas here the majority was non-resistant. So in just 4 generations, you can see how that resistant gene has spread to most of the population. If we were to continue this for a 5th generation and the permethrin was to kill off 10 more, we can only kill off 4. So 1, 2, 3, and 4. Then the rest of these resistant ticks would multiply and all of generation 5 would be resistant at that point. So you can kind of see visually what that looks like. All right, so hopefully this was helpful. What you will do now is you're going to go back to your eClass page and you're going to now take the exit ticket for this activity. Thanks, bye.